Come back. Example 3. This is a long example. Evaluate integral square root 16 plus x squared over x squared dx. This is a plus, so that calls for tan. X is 4 tan theta for the given domain. Then dx is 4. Derivative of tan is secant squared theta d theta. Therefore, square root of 16 plus x squared is square root of 16 plus 4 tan theta squared, which is square root of 16 plus 16 tan squared theta. Get 16 common, you have 1 plus tan squared theta. 1 plus tan squared theta is nothing but secant squared theta. So square root of 16 secant squared is 4 secant theta. That's what the numerator is. Alright, x is 4 tan theta. So x squared will be again 16 tan squared. Alright, so you have numerator and denominator. In all, 4 secant theta for the numerator, 16 tan squared theta for the denominator. You get one of the 4's reduces. You have 4 in the denominator. Simplifying secant and tan squared in sine and cosine, you get cosine theta for the numerator, sine squared theta for the denominator. So your original integral is now cosine theta in the numerator, 4 sine squared theta in the denominator, and dx is 4 secant squared theta. Okay, secant is 1 over cosine, so that gets you cosine squared in the bottom, but a cosine in the top reduces the degree, so you have a cosine in the bottom. That 4 reduces this 4, so there's no more constant left, d theta. Now, how do we find its integral? Well, here is a way. This is right. So I have multiplied numerator and denominator by cosine, increase the degree of cosine in the bottom, and I have cosine in the top. Why did I do that? You see, we can replace cosine squared by 1 minus sine squared. Sine squared is as it is, cosine in the top as it is. So I've rewritten cosine squared as 1 minus sine squared. At this point, you can use substitution u equals sine. So this gives me 1 minus u squared in the bottom. This gives me u squared in the bottom. What is cosine theta? If u is sine theta, cosine theta d theta is du. That's the numerator. So now here you can just separate these out. Factors. Half of 1 over u squared plus 1 over 1 minus u squared. This further factors 1 minus u, 1 plus u. So you can split this as 1 over 1 minus u plus 1 over 1 plus u, half of that. This term is nothing but u to the power negative 2, integral of all this. So that half comes out, integral of u to the negative 2, and then integral of this quantity. Okay, so half and a half gets me 1/4. So at this point we are almost done. Integral of u to the negative 2 is negative 1 over u. So that's resolved here. 1 over 4 is fine. Integral of this is natural log, except because of this minus, I have a negative here. Okay. Lastly, integral of this is again natural log plus a constant of integration. Now go back to what u was and resubstitute. So u is sine theta. So we have resubstituted u to be sine theta. At the end, let's remember what theta itself was, right? X is 4 tan theta. So sine theta is x over square root 16 plus x squared. One way of thinking about this is look at tan theta and look at secant theta. You see? So tan over secant is sine, and that's what you have done here. Tan over secant. So the 4's got cancelled and so on and so forth. So that's your sine theta. All right, and that completes the discussion here. So it's a longish solution, but all it called for was substitutions. Another example with a plus. So when you have a plus, you're going to use tan. X is going to be square root of 16, that is 4 tan theta. So dx is 4 secant square theta d theta. So square root of 16 plus x squared, we just saw, is 4 secant theta. So all of this is 1 over x squared, square root 16 plus x squared. 1 over x square, so that's 16 tan squared times square root, that's 4 secant. So 16 times 4 is 64, that stays in the denominator. And when you simplify it, rewrite it in terms of sine and cosine, you get this quantity. Dx, on the other hand, is 4 secant square theta. Okay? So 4 secant square theta. So again, secant is 1 over cosine, so right over there, so that cancels. Now again, use the substitution, u equals sine theta, u squared, and numerator is du. If u is sine theta, derivative is cosine, so all that is du. Du over u squared, but we just saw integral is with a negative. And you notice constant floating around plus a constant. Don't forget what was u. U was sine theta. Don't forget to resubstitute. X is 4 tan, sine is tan over secant. So that's what this is. You have in all, where you have sine theta, you would need x over all of this. Okay, so sine is in the denominator, so x here, the denominator of sine over here. So that's your final answer for this question. Okay, here are some simpler substitutions. Evaluate. Integral 2x over square root x squared plus 9. So that's a plus. It is very tempting to set x equals 3 tan theta. But notice the 2x. Substitute u equals x squared plus 9. Then du is 2x. That's the catch. Okay. So derivative of this is here. So you don't need trigonometric substitution. So 2x dx is nothing but du. X squared plus 9 is nothing but u. So you are looking at integral u to the negative half. Its integral is straightforward, right? So 2 square root u plus c. But u is x squared plus 9. So that's your integral. So notice sometimes you need trigonometric substitutions like here, but sometimes you don't. Okay. Now here is 1 over square root x squared minus 16 dx. Now x squared first, so this is some kind of a secant. So take square root of 16, that's a 4. X is 4 secant theta. So what is dx? It is 4 secant tan. Derivative of secant is secant tan. So dx is 4 secant tan d theta. So what do we have? X squared minus 16 is 4 secant squared minus, sorry, that should be just a secant. 4 secant squared minus 16. So 16 secant squared minus 16. So that's 16. Secant squared minus 1 is tan squared. So now you have square root. X squared minus 16 is square root 16 tan squared. So that is 4 tan. So this expression denominator is nothing but 4 tan. Whereas dx is 4 secant tan theta. So when I take integral of all this, I get numerator because of dx gives me 4 secant tan theta d theta. Denominator is that expression 4 tan theta. That cancels 4 and tan theta, you are left with secant theta. Integral of secant is natural log absolute value secant plus tan theta. Now you already know what is secant, x over 4, and you know what is tan. Tan is square root x squared minus 16 over 4. So natural log x over 4 plus square root x squared minus 16 over 4. Okay, we'll come to the next problem in our next video. It seems to be a longish solution.